Let's set up Whisper.cpp. Now, this is the GitHub repo. I'm going to be dropping the link also in the description below. And let's scroll down. It's really easy to set up, and we're going to clone the repo. That's the first thing we're going to do. I'm going to be doing it in the modules directory, and I'm going to right click on the modules directory and open an integrated terminal, and I'll paste what we copied, hit enter, and it's going to clone the repo. And once this is done, let's see the next step. We have to actually change directory to whisper.cpp. See, since we're in the modules directory and it is cloned to whisper.cpp, we can just change directory to, and we're here, and we hit enter, and this command is going to download base.en. That's one of the models that is actually available for Whisper CPP. And let's check this out. Now, you can see over here, we have then download one of the Whisper models. There are a lot of Whisper models, and if we right click and open a new tab, now let's scroll down. You're going to see the list of available models, and we have tiny, we are to large v3. Now, the smaller they are, the less accurate they are to transcribing audio, and the smaller they are, the much faster they are. Like in terms of VRAM consumption, you're going to have less VRAM consumption if you're using something like tiny or tiny en, or if you're using base en compared to if you're using large v3. But if you want better accuracy or more accuracy, you're going to have to go for large dash v3. I can run large dash v3, and you can too, but since I want this to be really fast and I want to reduce the latency, I'm not going to be running it. But if you have more than enough VRAM to spare, you can definitely go for this, or go for the quantized version. And since for the sake of this video, I'm going to be going for base.en. That's what I'm going to be going for. So if you look here, this command downloads this model, and if you want to go for any other model, you can substitute this for this if you're going for the large dash v3. Now let's go back. Since we've copied it and we've pasted it, let's hit enter. Now it's going to download this model, and let's go back to the browser, and the next thing we're going to do is make. So once it's done, we are going to run the make command. So I ran into a network issue while trying to install it the first time, so let's run it again, and this time we're going to just speed it up. So it's done downloading, and let's run the second command, and that is make. Now let's copy the new command, which we'll use to transcribe an audio that's here. So let's see how well it can actually transcribe this audio. Let's paste it in and hit enter. And as you can see, and so my fellow Americans, ask not what your country can do for you, ask what you can do for your country. Yeah, so it's really perfect. Now, since we want to enable CoreML support, let's go to the next phase, which is pretty simple. Scroll down, you're going to see CoreML support. Now, that's the reason why I added this in our requirements.txt and this. So now let's generate the CoreML model from this model which we actually downloaded earlier. And if you did download the large dash v3, you can just substitute this for whatever model which you downloaded earlier. So let's copy this, and we're going to run it. So this should take a while, so let's just speed it up. Okay, it didn't take that long, so let's go to the next command. Let's just copy this and let's run it all. I think this is the one that would actually take quite some time, and let's accelerate the video. Okay, and it didn't really take that much time. So let's transcribe. So since we run this for the first time, it should just take a short while. So let's wait. And if we run it the second time, it shouldn't take this much time. So let's see. Okay, it has actually transcribed. It's really good. It's actually transcribed it perfectly. So let's run it again. As you can see, it didn't take as much time as it did the first time. So let's take a look at the listing function that we have in the voice.py, and the voice.py is located in the services directory. And if we go over here, as you can see, we have the listing function. This function is going to enable us to utilize Whisper CPP. And at first, what it does is we set the transcribed file to the output directory. It's going to create a directory called outputs. It's going to be on the root directory. It's going to be here in the project directory, and it's going to save this file. If you look here, as you can see, we have this particular function to actually remove the file. We actually commented it out, but you can actually totally leave it in, so it will just automatically delete the file once it's done transcribing, because the transcription happens here. So let's go back to the top. So if you look over here, as you can see, we actually commented out the part that uses socks to access our microphone. And if you want to use socks and you do not want to use the speech recognition library, you can just uncomment this and comment this part out. So as you can see, now if you look over here in the arguments for socks, we have the transcribe file. So basically it's really short, like it's really short compared to using speech recognition, but I do prefer using speech recognition because it has a lot of functions that are really handy. So let's undo that, and let's see over here, we have the recognizer and we have the microphone. And if you look over here, we are setting the sample rate to 16,000. This is because that is what Whisper CPP actually requires. The WAV file that we are going to generate from our microphone, it has to be a sample rate of 16,000, and it has to be 16 kilohertz for the bit rates. Like, it's really important. That's the reason why if you look over here in the arguments for socks, we have 16,000, and we also have 16. So as for this, we set the sample rate to 16,000. And we select the microphone from the sources of audio, and we have the recognizer, and we adjust for ambient noise. I do not know if it actually makes any difference, but we'll see. Let's uncomment this and we can actually try it out. So we do have this, and then we have say something, and then it listens to it and get the audio data here. And if we look over here, here is where it actually saves the file, and it writes the audio, it gets the wave data and it writes it to transcribed file. So we pass the transcribed file over to the process audio function. Now the process audio function is below this, and as you can see, it accepts a WAV file and it also accepts a model name. Just in case we have large-v3 or we have small.en, we have other models that we want to actually use. We can actually specify it here. If you look here, we can actually specify it in the process audio function. We can just, if you look over here, as you can see, it's model name. So because it actually accepts this, but by default it's set to base.en. So it sends it in here. And as you can see, we have the models directory, we have the whisper.cpp, and wherever you actually keep your models, that's where you want to point this to. So I keep my models in the models directory /whisper.cpp/models. Go over here, whisper.cpp, and we have models, as you can see. And if you scroll down, you see ggml-base.en. That's what this is for. Now it checks if it actually exists. If it doesn't, it throws this error that it's not found. And it also checks if the wave file that we actually passed in actually exists. If it's not, it throws the error. Now this is the full command, so it's going to use subprocess to run this and get our transcribed text, which it cleans up here and it returns here. It's really simple, and at the end of the day we are going to return the output because that's all we need to pass to the LLM. So let's test Whisper CPP, and we're actually calling it here in the main.py to just out. Hello, how are you doing? I hope you're good. Is everything going all right? Are you really sure? So welcome to my YouTube channel. I am Austin Brain, and this is the Tech Giant YouTube channel. It's actually Austin Brain, not Brain. Okay, goodbye. So that's really it, and thank you for watching. Make sure you do like, make sure you do subscribe, and have a lovely day.